find the exact value of the trig function. We'll start by finding the sine of pi. Every time we're asked to find the exact value on these, we start with what's being plugged into the function. That would be pi. If we're using a unit circle approach, then we go on the unit circle to where pi is located. We find its terminal point, which in this case is -1, 0. And then we use the definition associated with sine. That definition associated with sine is saying that sine goes with y once we know what the point is. So the sine of pi is simply 0. Now let's do the cosine. Cosine. Let's take the cosine of 3 pi over 4. Find an exact value of a trig function. If we use a unit circle approach, we start with the fact we're plugging 3 pi over 4 in. We take note of the denominator here being over 4. So in terms of key terminal points to remember, anything over 4, going back to that first quadrant, x is root 2 over 2, y is root 2 over 2. What we need to appreciate, though, is the quadrant we're working in so we can figure out the signs on the x and the y coordinates. So, one way to do it, if you've got the unit circle, I go back here, 3 pi over 4, I'm thinking 3/4. If I start here, there's 1/4, there's 2/4, there's 3/4, I'm in the second quadrant. In the second quadrant, we could say, all right, x stuff is negative, y stuff is positive. That's one way to do it. So x is negative, y is positive. The other way to do it, what we also reviewed, was the all students take calculus, right? We now know we're in the second quadrant, and in the second quadrant, only sine and cosecant stuff would be positive. Since we're finding cosine, this has to be negative, so it would make sense here, since the cosine goes with the x, we've got a negative root 2 over 2. All right, number 3 here, let's find tangent. Tangent of 2 pi over 3. So you start with what you're plugging in. You've got 2 pi over 3 we're plugging in. Denominator is 3. So remembering what pi over 3 is in the first quadrant, you've got 1/2, you've got root 3 over 2. Understanding where 2 pi over 3 is located, again, I can go back to the circle here, count it out if I need to. You've got 1/3, 2/3 is going to be over in the second quadrant. So x is negative, y is positive again. There's the terminal point that's going to be connected to 2 pi over 3. By definition, tangent is going to be y over x, so I'm taking root 3 over 2. I'm putting that over negative 1/2. These denominators, which are the same, cancel out, and I am left with simply negative root 3. Which makes sense, because if you attach this on, this is something you're just more comfortable with dealing with. Knowing we're in the second quadrant, once again, only sine and cosecant would be the positive stuff here. This is a tangent idea, so answer had to be negative. Another way to check. All right, let's move on to some reciprocals. Like I said, I want to do one of each, so we got 3 to go. Let's go to cosecant now. Cosecant of 7 pi over 4. If you're going to find the cosecant of 7 pi over 4, starting with the fact we're plugging in 7 pi over 4, and the denominator is 4. Pi over 4 in the first quadrant, we got root 2 over 2, root 2 over 2 is our terminal point. 7 pi over 4, if we count it out, puts us down in quadrant number 4, right? So in quadrant number 4, x is positive, y is negative. Finding cosecant, we appreciate cosecant is the reciprocal with sine. So if we know that sine goes with y, and the y value is negative root 2 over 2, reciprocal would be negative 2 over root 2. And just for good measure to check if this is an approach you like. We're down here in quadrant 4 where only cosine and secant could be positive. We're finding cosecant, so that's why it's negative. Let's look at the secant here. Secant of, all right, let's play with an intercept. We start to get in this mode where we're playing with pi over 6, pi over 4, pi over 3 all the time. Let's play with an intercept. You got 3 pi over 2. If 3 pi over 2 is what's being plugged in here. Terminal point associated with 3 pi over 2 is 0 and -1, brought to you by the unit circle. Secant, well, that's the reciprocal of cosine, right? Cosine would go with this x value of 0. What is the reciprocal, though, of 0 since we're finding secant? Reciprocal of 0 is undefined. Doesn't work. So here the secant of 3 pi over 2 would be undefined. So that we've covered all our bases, cotangent will be the last one. And we'll just stick with the first quadrant stuff here. We haven't done anything over 6 yet, so let's do pi over 6. You take the cotangent of pi over 6, terminal point associated with pi over 6. That's going to be root 3 over 2 and 1/2. Cotangent, yes, is the reciprocal of tangent, but here I'm just taking x over y, right? So I take root 3 over 2, put that over 1/2. There's your x over your y. Everything's all positive because we're in the first quadrant, right? Remember that. 2's cancel out. Cotangent of pi over 6 going to be the square root of 3. Okay, there's a little review of how we're finding exact values using the unit circle.